So we're doing problem 11.9a on page 698. We've determined that x bar is 118.6, mu was 115, our n was 25, and what did they say our sigma was? 30, right? Okay, so what we're going to do now is we're going to do a test statistic. So our test statistic is x bar. I'm going to write the formula out. Okay. So our x bar is 118.6 minus 115 over 30 divided by the square root of 25. Now, let's do it in your calculator, except that we just have one little issue. My calculator's broken, so I need to borrow someone's. When you go to do a free response problem, this is what you need to show. Both of these would be good, but definitely one with numbers, okay? Now, we're going to go to stat over to test. And we have a one sample z-test. How do we know that? Because that's what they said. So we're going to hit enter. Just like confidence intervals, they're going to ask us, do we know data or do we know stats? Okay, so data is something that we've entered into a list. Did we enter anything into a list? So we know stats, and we're going to hit enter. Now, what did they say our mu was? So we're going to put 115. What is our sigma? What is our x bar? Was 118.6, right? We had 25. Now, that professor thinks what? She thinks that it's going to be greater than the 115, right? So remember yesterday I told you, anytime you go to use your calculator, when you go into your calculator, see where the mu is, see all those things? That is your alternative hypothesis. It's never based on your null hypothesis. It's based on your alternative hypothesis. So she said she thinks that the study habits of older people are higher, right? Boy, you guys are really tired today. So we're going to hit enter. And then you're going to scroll down. You guys, you're either going to pick calculate or draw. If you pick draw, it's going to draw the normal curve. If you hit calculate, it's going to calculate for us, and that's what we want to do. So hit calculate. So do you guys see the Z? See the Z right here? That's your test statistic. So my test statistic is 0.6. My p-value equals 0.2743. And let's scroll out so that you guys can see that. So, what are you saying, Miss Fleury? I'm saying you're going to write this out. You're going to put this stuff into the calculator. You're going to get your p-value. Okay? I showed you your table. I'm going to tell you that the majority of the time when you go to use the table, your p-value, your z-star, not your z-star, your test statistic is not going to be on that chart. Okay? But you should be able to say my p-value is going to be between these two numbers. So again, that's my p-value. Okay, so now let's just talk about, is it significant at the 1% level? Is this significant at the 1% level? Okay, so let's compare it, you guys. So let's think about this. 0.2743 compared to 0.01. Is my p-value greater than or less than? 0.2743 compared to 0.05. Greater than, less than? 0.2743 compared to 0.10. So, is it significant at these levels? We would fail to reject. You guys, the only time you reject is when it's smaller. So it is not significant. In order for it to be significant, it has to be less than those significant levels. Okay? Now, how did I know it was greater than? How did I know to put greater than in it? Because she said in the problem, she believes that the study habits of older people are greater than the norm. Okay? Now, you want your p-value to be small in order to be significant.